Alright, hey guys, this is GL Chapter 7, Section 4, Similarity in Right Triangles. Okay, so we have a theorem here, and the theorem says, okay, I see how this is going, that if we have a right triangle, and this right triangle A, B, and C. Okay. A, B, and C. This is the right triangle here. And we have the altitude. Altitude is basically the height of the triangle. So the altitude comes down right here. And it connects over here at point D. This altitude forms other right angles right here. So it's a perpendicular section from the vertex of the 90-degree angle down and forming two other 90-degree angles. What Theorem 7.3 says is that this altitude helps form two other smaller triangles, and they're also smaller right triangles. Okay, so we have the original triangle ABC, and then we have this smaller right triangle, and this smaller right triangle is ADC, and then this guy over here would be CDB over here. And this sort of be like a medium-sized triangle. Alright, so when we have this situation where the altitude, this CD, like I said before, is called the altitude. CD is the altitude. And remember, the altitude means that I come out from one of the vertex, I come straight down, and I form a perpendicular intersection. In this case, it's going to be the altitude from the 90-degree angle out to the hypotenuse. Altitude from the 90-degree angle out to the hypotenuse, and what happens is that it forms two other smaller similar triangles. These triangles are similar. So what Theorem 7.3 says is that if the altitude if the altitude to the hypotenuse divides a right triangle into two smaller right triangles, then those triangles are similar. Alright, so then triangle ABC is similar to triangle ADC. Triangle ABC is similar to triangle CDB, and triangle ADC is similar to triangle CDB. All of these triangles are similar, but it has to be from the altitude to the hypotenuse. The altitude from the 90-degree angle to the hypotenuse. And remember, the altitude forms 90-degree angles. Theorem 7.3. We're not going to be dealing with proofs of this scenario. So you can use okay. So for this one, they give us a right triangle, and they want us to write the similarity statement from the others. So the easiest way to do this is 90 degree, is to the easiest way to do this is to remember, this comes here and forms 90. We can sort of draw it out with this smaller guy. So here's the smaller guy here. Actually, no, that's not what I wanted. Short. There we go. That's what I want. Here's the 90-degree angle. So the 90-degree angle here is at S. So I base everything off of that. The hypotenuse is going to be QP. The short side is going to be SQ. Here's the short side. Here's the hypotenuse. This would be the longer leg. So this is the shortest leg. So this is S to Q. And that would be to P. So that's how I base it. This is the shorter guy. This is the longer leg. That's the hypotenuse. And then that's the 90 degree. When I draw this side, again, I base everything off of the 90 degree. So if we look here, this guy is the short leg, SP. This is the long leg, SR, and the hypotenuse is RP. So if I was to draw a bigger version, so I'm clear. Oh my gosh, this is my 90 degree. So that's my S. S is the 90 degree. The short leg is S to P, right? This is smaller than this guy. So then I go S to P. The hypotenuse is P and R, P and R. So these guys are all similar. So I can say that triangle let's go from let's go Q, R, P. Let's go for the 90 degrees. P, Q, R. This is the shorter side. So P, shorter side, longer side. So P, Q, R, similar to SQP, which is similar to triangle. I should move it down here. PQR, similar to triangle SQP. PP, which is similar to triangle SPR. Okay. Notice something that SP is shared by both the small triangle and the medium-sized triangle. The long leg, and we'll get to that. The long leg here, SP, is the same thing as the short leg of the medium triangle. So the long leg of the short triangle is the same thing as the short leg of the medium triangle. So they want a similarity statement with SR to PQ, or SP. SR, SP. SR to SP. So notice that this is the long leg over here, long leg over here, short leg, short leg, hypotenuse, hypotenuse. Same thing over here, short leg, long leg, hypotenuse. So here it looks like we have the SR, SR. So SR is the long leg of the medium-sized triangle. SP is the long leg of the small triangle. Write two different proportions using the ratio SR. So SR can equal we can say the long leg of the short triangle, SP, okay. SP, which is the long leg, actually, what is this? This is from small to medium. We can say QP, or medium to small. So this is the medium triangle over the small triangle. So we can say SR to SP. We can say on this side can be short legs. So PS to SL. I mean QS. Or we can compare it to the overall triangle up here. So if we do SR to SP, we can compare on the other side short legs too and say PS to QP. And we'll get the same ratio because they're all similar to each other. And you can actually do others as well, depending on what you're looking for. Okay. Okay. Geometric means. They say that a geometric mean is means that occur frequently in geometry, and they take the form of A of x equals x over b. So geometric mean there are means that occur a lot in geometry, so instead that we give it an equation. and it's in the form of a over x equals x over b. So the geometric means, these guys are the means. That's a mean. And when we talked about doing means and extremes and with proportions, these are called the geometric means because the geometric means are always the same. They're always the same. So because they occur so much in geometry. So much so that we have this equation that sets the means equal to each other. And they're definitely here with, say, similar right triangles. So if I wanted to find the geometric mean of 4 and x, 18, 4 would be in the numerator, x would be in the denominator, x would be in the second numerator, and 18 would be down here. I would cross multiply. X times x is x squared. And then 4 times 18 is 72. And then I would square root both sides because to square root means that cancels out the square. It gives me x by itself. And it'd be the square root of 72. I could pull out a 9 here. 9 times 8. The square root of 9 is 3. Let me make this bigger. Alright, so 9 times 8 equals 72, so I can pull those out and square root it. The square root of 9 is 3. Actually, I can pull this out as 4 times 2. So I could have pulled this out as 36 times 2. So let's change that. 36 times 2. Square root of 36 is 6. And the answer would be 6 square root of 2. Okay. 6 square root of 2. So we try to pull out the perfect squares to get that guy. All right. We have our right triangle. Nope. All right. Try this again. Okay. We have a right triangle. We come straight down. Okay. We have our two smaller right triangles. If we look at the little triangle in here, this guy would be my, I don't really look too accurate, so he's killing me with this eye. Try it again. I think my angle is just too off. There we go. I think that's more like it. This thing getting on my nerves today. Okay. Here we go. This is my 90 degree. And I will take this. Perfect. Well, not perfect. Better. Okay. So here's my overall triangle. The overall triangle, this is my short leg. This is my hypotenuse, opposite of the 90 degree. This is of the overall triangle. Here's my long leg. Obviously, you can see that. Here, for the I'm going to draw this off just to let you know. So the short leg of the overall triangle, long leg of the overall triangle. Of the short triangle, the small one, this guy here is the 90 degree, so this guy is the hypotenuse of the little guy. This guy is my short leg, and this guy is my long leg of the medium-sized triangle. Of the medium-sized triangle, this guy is the 90 degree, so this guy is the hypotenuse. This guy is the short leg. This guy is the long leg. So if you look at it, we have things that overlap. The hypotenuse of the short leg is the same thing as the hypotenuse of the small triangle rather is the same thing as the short leg of the overall triangle. The hypotenuse of the medium triangle is the same thing as the long leg of the overall triangle. And then the long leg of the small triangle is the same thing as the short leg of the medium triangle. These guys overlap. So much so that we can create three separate geometric means, right? We have two guys that are the same here, two guys are the same here, two guys are the same there. We can select three separate geometric means to account for these scenarios when we set up our proportions. And the first one is going to be the geometric mean of the, they call it corollary to 7.3, or the geometric means of the, let's see, to the altitude. The geometric means of the altitude. And it says this. Here's the geometric means of the altitude, or corollary to 7.3. Here's my altitude. Oh, good Lord. And I can set it up so that the short leg of the small triangle, so this is going to be small and medium, the short leg of the small triangle over the long leg of the small triangle. Actually, over the short leg of the medium triangle is equal to the long leg of the short triangle over the long leg of the medium triangle. But remember, the long leg of the medium triangle is the same. These guys are the same, so I can just put my x's here. These two guys are always going to be the same. Okay, these two guys are always going to be the same. And it's this guy right here. All right, these two guys are always going to be the same. Now, if we do this in terms of the letters of the Q, S, P, R, the short leg we can say is QS. The long leg here we can say is SP, the short leg, and then the long over here is SP. They're the same, and then this would be SR. And what did I do? Small to medium. Okay, and that's the geometric means of the altitude. And the why they call it geometric means of the altitude, they call it corollary to 7.3. Dumbass name when they have another name for it. Is because the thing that they share is the altitude of the overall triangle. The altitude of the overall triangle is the long leg of the small triangle, and it's the short leg of the medium triangle. And that's the geometric mean. Those are the two guys that they share. The two guys that they share is the means is the altitude is the long leg of the short triangle, short leg of the medium triangle, and that is the geometric mean. That's what they share. So they do an example here with a triangle with numbers for the explanation. They said this is 2, this is 8, this is 4. This 4 is the geometric mean, so if I was to set this up, it would be 2 over 4 equals 4 over 8, right? And this is 1/2 and this is 1/2. If I was to cross multiply, it'd be 16 equals 16. Okay. They call it segments of the hypotenuse, altitude of the hypotenuse. Okay. This is my hypotenuse of the overall triangle. The altitude cuts the hypotenuse into two separate segments. Here is the small segment. Here's the large segment of that cut. The small segment applies to the small triangle. The long segment applies to the medium triangle. So that's what they mean by segments. So this is going to be part of the hypotenuse in terms of the small side. This side is part of the hypotenuse in terms of the medium side, or the medium triangle, and these two guys are part of the altitude. The altitude of the overall triangle itself. Alright, so we have two more equations with this scenario, and I don't know why they use a different dang old triangle. And they have it in a different orientation. So corollary to 7.3 has two ratios. Perfect. Alright, here's ABC. Here's D. Okay. Here's the opposite of my 90. Here's my short leg. So all of this applies before. This is the overall hypotenuse of the medium triangle. Oh my gosh. Of the medium triangle. This is my hypotenuse. This is my short leg. And this is my long leg. Okay. Of the overall triangle, this is my long leg. This is my short leg. Of my small triangle, this is my hypotenuse. And this is my short leg. Yeah, this is my short leg. This is my long leg. Okay, so we did the altitude. The altitude is where they share the altitude of the overall triangle. Now we're going to do the legs of the overall triangle, and look what they share. They share the hypotenuse on the left hand side. The short leg of the overall triangle is the same thing as the hypotenuse of the small leg of the small triangle. And then the long leg of the overall triangle is the same thing as the hypotenuse of the medium triangle. So that's called the geometric means of the legs, or corollary to the 7.3, what they call it. So here's the overall hypotenuse. So this is the big triangle over the small triangle. And it's going to be the hypotenuse over of the big triangle, the overall triangle, over the hypotenuse of the small. That guy is equal to the short leg of the overall triangle over the short leg of the small. And remember, this is geometric mean, so these two guys are the same. So when I set this up, it's going to be AB let me do it over here. AB over AC, and that's going to be equal to AC over AD. Alright, that's the first one. The second one, it's going to be the big overall triangle over the medium triangle. And that's going to be, again, hypotenuse of the overall triangle over the hypotenuse of the medium triangle. That's going to be equal to the long leg of the big triangle, which is over the long leg of the medium triangle. And that gives me the hypotenuse is AB again. Now the other guy is going to be CB. And that guy is also the leg of the overall triangle. So CB again. And that's going to be over DB. Alright. Those two are always going to be the case. Alright, so they want to know what the value of X and Y is. So to find Y, I'm going to use the geometric means of the altitude. So I can say 4 over Y is equal to Y over 5. Again, the altitude is shared by both the medium and the small triangle, so that's going to be Y squared equals 4 times 5 is 20. I'm going to square root both sides. So Y equals the square root of 20, which is 4 times 5, square root both sides. So Y is equal to 2 times the square root of 5. Alright, to find X, I'm going to use the corollary number 2, or means of the leg. And that's I'm going to add the 4 and the 5 because I need the overall hypotenuse. And that's going to be 9 over X is equal to X over 4. The X touches the 4, so it's going to be X over 4. Cross multiply, I get X squared equals 9 times 4 is 36. Square root both sides. X equals 6 times 6 is 36, so X equals 6. The robot must turn right from D. Go to D, turn right. To point B, okay. To put the bottle in the recycling bin, how far does the robot travel from D to B? Alright. Alright, so looking at the initial problem, D to B. X plus 9. Let's see. X is 16. Okay. So X is 16. So to do this guy, it's geometric means of the altitude. So I have this guy, this guy, this guy, this guy. This is 9. From the previous problem, this is 16. And I want to find out what this guy is. So they both, this is the medium and the small triangle, they both share the altitude. Here is the short segment, here's the long segment. So when I set this up, it's going to be 9 over x equals x over 16. Right, so this is the short leg of the small over the short leg of the medium, which is equal to the long leg of the small, which is also over the long leg of the medium. Cross multiply, x squared equals 9 times 16, which is 144. Square root both sides. X equals 12. Yeah. All right, that is this section. Hope you have a great rest of your day.